Hello everyone. In this video, I'll be discussing association rules, how to mine association rules, how to apply the confidence difference criterion, how to apply the confidence coefficient criterion using Python. So let's begin with definition of association rule. So association rule mining is a method for uncovering relationships or patterns in datasets, especially transactional data. These relationships are typically expressed as if-then statements. For example, in a grocery store dataset, we might find a rule such as if a customer buys milk, then they are likely to also buy bread. In this association rule has two parts, means this rule has two parts. First is antecedent. In this, the if part, example milk lies. Second, consequent. In this, the then part lies. For example, bread. And there are association rules which evaluate using three main matrices. First is support. In support, the proportion of transaction that include both the antecedent and the consequent. The formula of support is transaction with antecedent and consequent divided by total transaction. Second we have is confidence. Confidence means the likelihood that a consequent is bought when the antecedent is bought. So the formula for confidence is transaction with antecedent and consequent divided by transactions with antecedent. Third is lift. Lift measures how much likely the consequent is bought when the antecedent than the antecedent by random chances. The formula for lift is confidence divided by support of consequent. These three matrices help us to filter out the most interesting and meaningful patterns. Then we have code related to association rule and and the output here is in the form of binary false and trues which can be represented in the form of zeros and ones. And here's the explanation of our previous code in which we load our sample data which contains five transactions each representing a list of items purchased. Then second we have is one hot encoding. In this, we use the transaction encoder to convert this data into binary format, where each column represents an item and each row represents a transactions. A value of 1 indicates that an item is present and 0 means that it's absent. Third is a prior algorithm. We call a prior algorithm with a minimum support of zero point 0.6. Only item sets that appear in at least 60% of transactions will be returned. Fourth step we have is output. We get a list of item sets with their support values. These item sets are the combinations of items frequently bought than others. And fifth we have is generate rules. In this we use association rule function to extract values from the frequent item sets. We specify confidence as the evaluation matrix and set a minimum threshold of zero point 0.7, meaning that the rule must have at least 70% confidence to the considered. Sixth and final step we have is output. The output displays each rule along with its support, confidence, lift, and other criterias and details. The next topic we have is how to apply the confidence difference criterion using Python. So let's start with the definition of confidence difference criterion. So the confidence difference criterion is used to evaluate association rule by comparing the confidence of a rule with the confidence of similar but simpler rules. Essentially, it measures how much likely an item set is to appear in the rule than in smaller related item sets. So the formula for difference is confidence, max confidence of subrules. For example, suppose we have the rules milk and bread, butter with a confidence of zero point 0.7. If the subrule milk, butter has a confidence of zero point 0.5, then the confidence difference would be zero point 0.7 minus zero point 0.5, which is 0.25. This value tells us how much more information the rule provides compared to the simpler subrules. Then we have how to apply confidence difference criterion. First is generate association rules. In this, we use an algorithm like a priori or FP growth to generate a set of association rules. Second we have is calculate expected confidence. For each rule, we calculate the expected confidence based on the support of the antecedent and consequent. Third step we have is calculate confidence difference. In this, subtract the expected confidence from the actual confidence of the rule. And fourth step we have is set a threshold. Determine a threshold for the confidence difference. Rules with the confidence difference above this threshold are considered statistically significant, and others are considered insignificant. Then last step we have is filter rules. Uh, the filter rules filter the rules based on the confidence difference threshold, as it was mentioned before. Then we have is a code related to confidence different criterion and the output with 95% confidence interval. And here's the explanation for code in which we import libraries such as NumPy for numerical operations. And we sample data, we define a sample data set. Here is the sample data with heights, which includes heights. And then we have confidence level in alpha. We set the desired confidence level, example 95%, and calculate the alpha. Then we have critical values. We use the t.ppf function to find the critical values from the t distribution based on the alpha level and degrees of freedom. Then we have margin of error. We calculate the margin of error using the critical value, standard deviation, and sample size. Here it is given margin of error, where critical and sample and standard deviation is given. And then last we have is confidence or confidence interval. We calculate the lower and upper bounds of the confidence interval. Here we are calculating the confidence interval and we are printing the 95% confidence interval and which shows in the output. So this was about difference criterion, and now we'll see how to apply confidence quotient criterion using Python. So let's start with the definition of confidence quotient criterion. So the confidence quotient criterion measures the strength of a rule by comparing its confidence to the confidence of a similar but simpler rules. Specifically, it's the ratio of the confidence of a rule to the confidence of a stronger related subrules. Here is the formula given for confidence coefficient criterion. Uh, and a confidence coefficient greater than 1 indicates that a full rule is stronger than any of its simpler subrules, which means that including both items in the antecedent provides additional predictive powers for the consequent. Then here we have the code related to the confidence criterion, quotient criterion, and the output, which is in the form of antecedent, consequent, support, and confidence. And this columns indicates, as I shown you, columns indicates antecedents, consequence, confidence. Here it is confidence and confidence coefficient. And here's the explanation for our previous code. So we defined a sample data with 6 transactions. Here are the 6 transactions, and we represent them which are brought together. We then use transaction encoder to transform the data set into a one hot encoded format, which means that we convert that into a single format, encoded format, with each column representing an item and each row representing a transaction. A value of 1 means that item is present and 0 means it's absent. Then we use the a priori function to find item sets that appears in at least 50% of transactions. This results in a new column, confidence quotient, that indicates how much stronger the full rule is as compared to its subrules. So these all three topics were related to association rules, and this was all about association rule. And thank you for watching.